All right, Slack with DHCP v6. So if the text on the screen isn't very readable in the video, good, that'll help me avoid being copyrighted by Cisco, hopefully, a little bit more, if it comes to it. But also just have the PowerPoint pulled open on your screen too, okay, to read it. And then you can either follow along to my voice or have it in a separate window. So, you know, if I'm trying to bring emphasis to something, you can see what I'm doing. All right. We are recording. Chapter 8. All right. So remember, you have the global unique address. What other types of IPv6 address are there? Anyone remember? EUI. No, so that's how that's one of the two methods for defining the host portion of the IP address. So we've got global unique. Come on, you guys need to know these. Global unique. What are the other kinds of IPv6 address? Two of them start with link.
Yeah, link local.
Link local, yes. Well, the other one doesn't start with local. Unique local. And don't forget about that, unique local. Yep, so link local, unique local, and global. Those are there's more than that, but you need to know those ones. All right. So when you go to statically assign an IPv6 address, okay, if it's anything besides the special unique local header, it's going to be a global. Okay, yeah, just remember you have the different types of prefixes, and those are significant. Does anyone remember what's the significance of this prefix? This this /32 right here. 2001 DB8. What is that? Why do we always see those numbers when we talk about IPv6? It doesn't matter if it's Cisco, anyone. If they need to,
Is that like their 192?
Kind of, yeah. Actually, there's no IPv4 equivalent to this. So typically we'll use the most common IP address that people see at home, which is 192.168, something, yeah. No, this is the documentation space. You can't use 2001 DB8. It's not going to be routed. It's not the loopback. That's : one. The very second IP address. The second IPv6 address. What's the very first IPv6 address? How can you get lower than : one? : which is equivalent to the decimal value of what's the very first numeral? The first numeral. Is it 1 or 0? It's 0. It's 0. It's not 1. The first value to be conceived, I don't know, is 0. So that's 0 and that's 1. What do you think 2 is? 2. 2. What is 10?
A.
A. Yes, it's A. That's right. Okay. A10, B11, C12, F15. All right. Hopefully that shows up in the video. I've also noticed that what Zoom Cloud spits out is not what the camera sees. The camera sees up until like this point, but Zoom only does to like here. That's fun, which reduces the resolution even further. Okay, good. Yeah, well, from my screen, it doesn't look so bad, and maybe in the stream, it doesn't look so bad, but we'll see what it looks like in the recorded and uploaded video. All right, but yeah, guys, and everyone, guys and gals, look at this. Error prone, yes. You think you're gonna do this perfectly? Well, they've got a colon in there, so they shortened it. But if do the all the characters 10 times, you're gonna make an error. Okay, it's not as easy as 12 digits separated by periods. Okay. Automatic IPv6 addressing. The way it works is through router advertisements, okay, RAs. Now, who do you think sends this? Router advertisement. Does the client send it or does the router send it? Router, okay? It's a router advertisement. Okay, the host will use it to give itself an IP address. So link local is automatically created. There's more to it here, but the interface did not create a global unique in the output right here. The network segment did not have a router. Okay, so yeah, the reason this line is blank is because there's no router and there's no DHCP. There's just no router. Okay. So the IPv6 router, you need to have one if you want to have automatic IPv6 assignment. Now this will happen, okay? But what is your FE80 equivalent to in the IPv4 world? What IPv4 address do you see if DHCP is not working? Not the MAC address. A PIPA. It's going to be a PIPA. What does a PIPA start with? What? 169.254. Okay, dot anything. That is a PIPA. Your IPv4 client will give itself something within this range just to talk to something else. IPv6, this happens by default, even if you have a global unique address. Every, man, I don't know what at the absolute minimum, I don't know what this number is, but every IPv6 client has multiple IP addresses. Okay, unique local, link local, and maybe a global unique. So that's equivalent to the FE. Yes.
I just had a question on GUA. I wrote it down as global unicast address. Is it
Global unique.
just looked it up and I'm pretty sure it's unicast, but I could be wrong.
I
I
think
wrote
of
it
it
down
as
from-
global unique, but
I might have written down the wrong definition.
no, you're good. No, you're right. It is unicast. Why has no one corrected me? It's unicast, global, whatever. It's gonna be different or the same outcome. But yeah, you're right. Global unicast address versus global, yeah. I think I say that. I told myself that a while ago to remember it. But yeah, global unicast. Did I miss it over here? Yep, I missed it right there. Global unicast. But it is globally unique. Okay, no one else has it. So you are on the internet proper with IPv6. All right, so So look at this output, the percentage here, this is what Windows does. Don't let that throw you for a loop. It's just what Windows does to keep track of the interface. Windows in its infinite glory has multiple ways to keep track of an Ethernet interface. Linux, ETH1, ETH2, well, sorry, ETH0, ETH1, ETH2, ETH3, ETH4. Windows though, it has a name, a friendly name that you give it, and then it has this value that won't change across boots, and then there's like another value. Anyways, it's a Windows thing, so don't get too freaked out. This graphic is extremely useful. Please use it. Okay. So 2 ways to get your GUA, global unicast address, stateless and stateful. So stateless means there's no central DHCP server to dictate. Okay, we just go by word of ear, or word of mouth. Basically, we go based off of what the router is advertising, and then we use that information, the prefix, and the fact that that is likely your default gateway that just broadcasted itself. So there you go. Here's your default gateway. So, and then we have the in-between where you still look at the RA, but within the RA, it says to you, go and talk to the DHCP-v6 for the rest of your information. So this is like, I like to call it half slack. So this is slack, half slack, and no slack. That's just the way I think about it. And then stateful, if you can remember this, stateful, serverful. Okay, it is, you have a server. Stateless is serverless. Well, sorry, no, you still have a server. It's just, the server is an option, basically. Well, it's not optional. You need to go, the router tells you what to do with Slack, okay? The router is telling you what to do with Slack. It's when you, fully involve the server. I know this right here contradicts what I just said, but the router just says go over here. It's just pointing a finger. All DHCP clients go this way, okay? Towards the server. All IPv6 configuration, except the default gateway address. I'm sure you could overrule that. I'm sure you could. All right. I don't know why they add in this module, like if you read about this in a different module, this is no longer the case. No, this is universally how the 6th version of Internet Protocol works. It's not just in this module, okay? ICMP v6 RA. Okay. Router advertisements. All right. That's a good thing to keep in mind. Okay, when we talk about what happens with Slack, half Slack, and stateful DHCP v6, the host can manually assign itself anything or decide to talk to a different IP address. Flags, you need to know about these flags. These three flags correlate directly with, these three methods. Okay, so automatic, the A flag tells it to do stateless. So that's full Slack. No server. And then this one, additional information. That's the other flag. So you would do this when you need to talk to the server for additional information, other information. So here you go. You have all the three different outcomes. The client sends, what does RS stand for? Anyone remember? Router solicitation. I solicit you. So just think about this for a second. Why do we see no soliciting signs in some neighborhoods? It's because the solicitors, the folks coming to your door to try to sell you something, they are soliciting your attention. And they want your attention to try to sell you something. You just say no soliciting. Okay, so if I, solicit you for some help after class in clearing the router configs, which by the way, some of you didn't do on Wednesday. So I'll leave that for your classmates to figure out. All right. Oh, who's at the very end over there? Station 9, you deleted iOS. Or station 10, you deleted iOS. Okay, be careful with that delete command. I want you to delete vlan.dat, not, you might have said delete flash. That's bad. You just formatted your hard drive. Windows is gone. And that's what happens when you format a hard drive. Everything is gone. You can do data recovery, but that's expensive. Okay. Oops. Yep, so router solicitation from the client, and then these are your three different outcomes. Slack only, so full Slack, half Slack, so Slack with DHCPv6, and then stateful DHCPv6, DHCPv6 only. Notice the other flag isn't involved in this last one. It kind of is. And the way when you go to configure this, you really do you type in in my opinion, it's convoluted. It's more than it should be to set these flags. You have to say, and it's different wording for the different flags, you'll see. So not every network has access to a DHCPv6 server. And quite frankly, you don't need one. With IPv4, unless you wanted to pay someone to be there on the clock, assigning static IP addresses, you needed to have a DHCPv4 server. It's not really an option. You can absolutely get away with not having a DHCPv6 server. You use IPv6. I can imagine most household routers, off-the-shelf routers, are gonna just be Slack. There's no reason to have all this extra processing and RAM usage and storage requirements to store the program that is the DHCPv6 server, when this can all happen through the protocol. We don't need a server. So the router is going to be sending everything, or sending these RAs every 200 seconds. How many minutes is that? You don't have to be exact, just give me
It's a change.
3.5. Yeah, almost 3.5 minutes. 3 minutes and 20 seconds. Do you want to wait 3 minutes and 20 seconds for your computer to access the internet? No, so that's why that router solicitation is there. The client will send out that broadcast, multicast, not a broadcast. So it's even more efficient. We don't have to broadcast everything anymore. RAs and RSs work through multicast. Yeah. Full slack, half slack, no slack. All right, so enabling Slack. Yeah, this is how you enable it. IPv6 unicast routing. That's it. Then the router is sending out RAs. This is all you need to do to configure automatic host addressing on a router. And someday this is going to be enabled by default. It just will. Okay. Yeah, with our new layer 3 switch over here, we had to go in there and say IPv4 unicast routing. We were so used to that being the default. But yeah, actually, I think it did. No, Greg did this. He did that command explicitly. So we don't know if it was there by default. We'd have to clear it out. Try again, but just keep in mind that you might need to do this with IPv4 even. All right, so IPv6 all nodes group. So this is all IPv6 devices. Remember that, FF02. So FE80, FF02, that's one you need to remember. And that is the all nodes group. All right, so notice right here, we have the global unicast address right here, and then we have the subnet. What's the difference between this number and that number? Where did the similarities stop?
CAD and EVA.
Kinetic,
ACAD, or, oh, sorry.
ACAD, ACAD, yeah. And then the colon. So it's all the same up until the colon. What's your network portion? Everything that's the same. That has not changed from IPv4. Okay, the network portions stay. It's when you change the host portion that things become within the same network still. Get into the host territory. And remember, each of these groups is worth 16 bits. So we've got 16, 32, 48, and 64. Okay, so right after the 1, it's implied 0001. That's the network portion. Whatever comes afterwards is assignable to a host. So this GUA right here, is that the first, second, third, fourth, fifth IP address? Which one? It's technically the second, yes. I believe you can assign : to an IP, to a client. Yeah. No longer do you have to worry about a dedicated network ID or broadcast ID with IPv6. I'm pretty sure I'm right, but I'm second guessing to myself because that's just so ingrained into understanding of IPv4. Yeah, I'm pretty sure you could just assign 0. I still wouldn't want to do that. I would use that for something important, like a server or router. all routers group versus all nodes group, FF02. Or wait, what did I?
F0:2::1. And then
I forgot the colon, yeah. That's what I did. Don't need it there. ::1, this is all nodes. And then FF02::2, that is all routers. As per IPv6 protocol, if something receives that or the equivalent of IPv6 unicast routing, it will put itself, if it's a router, in this group in addition that group. And then these RAs aren't sent to everyone. They're sent to the all nodes group. That's everyone basically, but the processing is more efficient. All right, so now we get into not just enabling Slack, but talking about how to configure Slack only or full Slack. The A flag is turned on, that's it. So this second part, Kate, that's what you were talking about earlier, dynamically creating its own interface ID or host portion of the IP address. That's where EUI64 comes into play. What is the other one? That's one method, EUI64. We'll talk about it. What's the other one called? EUI64. That involves the MAC address. But if I don't depend on the MAC address, what do I do? If I'm a computer, I make it up. It's usually what computers do if they don't know what to do. They make it up. AI. It makes crap up. There have been now several lawyers or lawyer clerks who have gotten arrested for citing fake cases. The AI was like, oh yeah, you can do this because that happened in the past, you know, case law. Nope, made it up, pulled it out of its AI. All right. But randomly generated. Okay, so EUI64 and then randomly generated. All right, those are the two differences, or the two ways to dynamically create your own interface ID. Otherwise, you can manually assign it, but you still have to care about that. We're not going to call it's not called network portion. It's the GUA prefix or global unicast prefix. It's equivalent to your network ID coming from IPv4. LLA, what does that stand for? Link local address, yes. All right, router solicitation messages. Or when it receives a solicitation. So the computer here sends an solicitation and the router responds with an advertisement. I think this would be relevant to know for later for some reason. But if R1, so according to this, R1 sends the R, yeah, after it gets the solicitation, but it sends the RA to the all nodes multicast address. Is that the most efficient thing to do? When I reply to one person, I address everybody. It's not the most efficient thing to do. But you know, that implies that the clients will have multiple chances to see that RA. Okay, all it takes is one device to speak up and then all of a sudden, every device has an up-to-date RA. So I almost wonder if that's configurable. If you get a solicitation, reply in unicast, not multicast. I don't know. I don't know what that would screw up either. So there's your two different methods for the interface identifier. So yeah, most of the time by default, your IPv6 networks are gonna have the first 64 bits be the global and the subnet bits. And then you get to play with and assign the last 64 to all the hosts. All right. So I realized recently, I've been telling my classes for like a year and a half, 2 years now, there's two IP addresses for every, two IPv6 addresses for every square foot, so about every one of these tiles. I'm wrong, there's about 2,000. Yeah, we're bad. We're really bad at understanding what the heck quintillion even means. I don't think it's quintillion, it's more than that. William, you're more familiar with these exponents, playing cookie clicker right now? Oh, nice. So yeah, play cookie clicker for like a month, and then you'll understand, you know, the differences between 12 zeros and 9 zeros, 6 zeros, 20 zeros, 21 zeros. All right, so which one your operating system does depends on the operating system with which method. So Windows 10 is going to randomly generate. Which one's more secure? Random is more secure. Could you reverse engineer and get somebody's MAC address and then OUI look them up? Yeah, you could. With EUI 64. The Slack host may use duplicate address detection. So even though the chances are super low, you still need to do it. It's a non-zero chance that you end up getting someone else's GUA. So that's how DAD works. Contrary to what you might think. DAD does not have a job. This is what he does. Oh, 18 quintillion, not whatever I said. Oh. The first 64. Oh, well, yeah, what happens if you have, you know, you could use 1 bit for subnetting, subnet bit, and then have, what would that be? 79 network interface bits. So your quintillion is exponentially higher. What's 18 quintillion times 18 quintillion 15 times? It's a lot. All right. DHCP v6. So this is no Slack, right? We're using a server. But the first 2 steps happen, that always happens. You do have to talk to the router. It's what the router tells you to do afterwards, which could bring up the server. Okay. So just this part right here, okay, it is a little bit more confusing because one of 2 things can happen in step 5, or, you know, DHCP steps 3. So SARR. Okay, most of the time you're going to do the request, I believe. If I remember correctly, it's a request, so SAR. And instead of DORA, we get SAR. And then if you're doing the information request, it's SARE. How would you say that? SARE? Sire? So it's one of the two. One of these two. Remember this is a stateful DHCPv6. Yeah, I mean, this is one place we could have. I mean, these words make more sense to what's actually going on instead of discover, offer, and all that good stuff.
Is the difference is step 5, whether it's stateless or stateless with DHCP?
Yes, I believe so. I think it shows us. No, it sends the, I think it, right, yes. This would be used with the other flag, and then this would be used with the M flag request. We're gonna see how that plays out right here. So if an RA indicates that a stateless DHCP method, so I just want to pop back here, so we use our terminology correct. Stateless DHCPv6, and then stateful. That full, if you get the full in there, that's full server, all the server. Stateless, using less server. And if it doesn't say stateful or stateless, you're not using a server at all. Stateless. So stateless DHCPv6. The host uses the information in the RA to contact the server for additional information. The DHCPv6 server only provides configuration parameters for clients and does not maintain a list of the address. That is why it's stateless. It's not keeping track of the state of anything. It's just handing out information. That's all. All right, so PC1 receives a stateless RA message. From the router, either automatically or because it solicited it. So something could have happened to make step 1 happen. But a flag is set to 0, or the automatic flag is informing it to use Slack. So it's going to give itself an IP address. And then the other, when it seeks information from the DHCPv6 server. Okay. But the M flag is still 0 because we took care of the IP addressing with the A flag.
So only A or N will be 1.
I believe so. Let's see. Oh, and then this last bullet point, PC1 sends a solicit message seeking additional information. which would put them right here. Yeah. This 3 is being sent from the PC. This 4 is coming back from the server. Okay, so the fact that the arrows are over here is significant versus the arrows on the left side of the PC. All right, and that is how you set the other flag. Okay, well, yes,
important. That right there is showing only the config interface. So to get to that config interface, is that just interface, whichever one it is?
Yep.
Like if you're looking at the one above it, it's the interface gigabit 001 is the one that's connected to the LAN, right? Right, yeah.
yes, so gigabit 001.
So to open that, to put that IPv6 ND other, you're gonna just go to whichever interface is the one that's connected to the LAN, correct?
Yes, whichever interface is facing in the direction which you decide to control the flags. That's what we're doing. We're neighbor discovery. And we're editing neighbor discovery functions for that interface.
Right, so well, in this case, and it's on, it's because it's saying show it, it's interface G001.
Well, they're doing, yeah, and then they're begin with neighbor discovery, so there's a bunch of stuff before that, but yes.
My point is though, is that, or the question is though, is that the command is just interface and whichever interface it is.
Yes.
Okay.
So this is why I started Packet Tracer. I've got a 4331 here, which is the same thing we have over here. So let's go into G0001. Oops. Oh, that takes it. Okay. It emits a leading 0. I don't think that happens physically. But thank you for programming Packet Tracer as such.
Right.
It's wonderful.
That's what I was looking for. Yeah.
So, okay, and then, I mean, let's just look at it, look at what's going on. IPv6. And we've got some stuff to do. Neighbor discovery, what's involved in here? Our 2 flags. So notice it doesn't say anything about the automatic flag because if you turn that off, you're turning off advertising, essentially. There we go, suppress. And that's probably it, yep. So I encourage you guys to do this, do what I'm doing. Explore the tree that is all of these commands by using the question mark. Seriously. These will start to look familiar. And then all of a sudden you're walking through this forest and you're like, ah, I've seen that tree before. It could be a different tree though, so keep that in mind. Because yeah, you could see stuff similar to this, some of it, maybe not all of it, from let's see what IPv6 in regular global config. Yeah, we get now they're pretty different. That's the same. Anyways, spend some time using that question mark. Okay, so I don't think they put a chart in here. No, they didn't. Over here, we've got Slack. AAC, yeah. Okay. You've got stateless Slack. So I'm just gonna put, well, stateless Slack And then we've got stateful Slack. Okay, automatic. What are the flags?
A1, 0,
1, 0,
0,
0. State. Right here.
1, 1, 0.
And then finally Slack here.
0, 1.
Or stateful Slack. It doesn't say in this slide. I think it's the next slide.
It's just. It's the next slide.
Yeah, this is telling us how to do. Yeah, and then it tells you in English right here. This might be a little bit more helpful. Hosts use stateless autoconfig, so remember. No one's keeping track of the IP address. That's all stateful and stateless means. IP address, are you keeping track of it or not? For the address, but then hosts will use DHCP v6. That's implied right up here. Or wait, yeah, show IPv6. DHCP v6 to obtain other configuration. So reading this English tells you why we call these flags the way we call them. All right, stateful DHCP6, there we go. M1. So yes, Skeeter, you're correct. Or wait, it was Aiden? Or was it
There's Josh.
Josh? Okay, yeah, you were asking about the different flags. Or,
Goes through.
Still Slack when it's stateful.
Say, because I don't think there's Slack for the last one. Because it's Slack, half Slack, and then no Slack.
you're right, it's not Slack at all. It's stateful DHCP. Right. There's a V6 back there. So there you go. Thank you for correcting me. Oh, no, I think. Yeah. Sorry. Slack is Slack. All right. RA has the M flag on. And that contains the IPv6 address of the server that it's going to use. So is this a stateful DHCP v6 going to keep track of, write down and categorize and file who has what IP address? It's going to keep track of that? Yes. Stateful server keeps track of all of the IP addresses. Managed flag, managed config. So what's the shorthand gonna be? Do you have to type out managed config flag? No. Waste of time. We can do. Oops. Then we did. Okay, we can just do O or M. That's all we gotta do. Yeah, I see everyone and you're doing your labs over here and you're typing out these full commands. If that's what you want, that's fine. But honestly, you're gonna do that, you're gonna use muscle memory more than anything else. That's my opinion. You know how you learn best, but I could just do M, tab. Okay, I could just do O, tab. There we go. I clicked the wrong button. So much faster. And by all means, use the tab to make sure that you're doing the right thing. I mean, they already have you doing shorthand anyways, neighbor discovery. So you're encouraged, and plus it's really impressive. The faster you can do something and still be accurate, that just shows how much time you've been spending doing this. And therefore, experience. Okay. All right, configure DHCP v6 server. Relay agent, that's really the important thing here. So as always, if you want to interact with or configure anything IPv6, you usually have to set that. School name, okay. So no, we don't need to exclude beforehand, at least according to these instructions. Does it even tell you how to exclude? Well, let's find out. Well, not according to packet tracer. All right, on a client, IPv6 add auto config. So that is a difference with IPv6. So so we can do IP add, right? DHCP. DHCP. But if I do IPv6 address, oops, IPv6 address, it's DHCP and autoconfig. Why is that? Why is that? It's because we're talking about the two types of DHCP versus the default. Slack happens by default. And that's autoconfig. And then versus DHCP. Okay? So that's what it looks like to assign IPv6 in different ways.
The DHCP one was stateless DHCP.
Either one. Either one. It's whatever that flag sense.
Oh, so if we would have already set the flag, so if we wanted to do stateful, we would have already set the flag prior to that.
Yes, in this context, let's see if I can get like a topology. Okay, I don't have a topology to look at here. So you have a router looking towards another router or server for IP addressing, which is totally possible, oftentimes in a SOHO environment. You have your router and it's connected to the internet through a modem or whatever to the ISP. Okay, you want this interface on the router to get its address automatically. Because the ISP could be changing up their logic and give you a completely different set of IP addresses. You know, they want to change what you have. They don't want to call you up and have you drive down or remote in and take the time to do it. Just set it to be DHCP. Now, if someone, very unlikely to happen, and there's things you can do. If someone, you know, does a man in the middle, you might be given a different IP address, but the router on the other side, the ISP router, isn't gonna route you somewhere else if the man in the middle happens, but it's not gonna, yeah. Very, very, very unlikely. Yeah.
You have to specify DHCP v6 on the command line.
No, that's implied already at that point.
You are an IPv6.
It's implied right here, IPv6, yeah, you're
Okay,
gonna be
so you're
using,
redundant.
anytime you see IPv6, it has nothing to do with IPv4. Nothing, nothing at all. Completely different protocol. And then when you don't see v6, it's implied IPv4. Okay, keep that in mind. I don't think they're ever going to make IP be IPv6. Maybe, maybe not in our lifetimes. No. Then you'll have to find yourself specifying IPv4 instead of the way it is now. So, yeah, keep in mind though, if you're gonna, no matter how you implement the DHCP v6 server, you have to set your flags. Especially if this is the only router. It's delegating to the hosts how they are supposed to go about one of three ways to do their addressing and other configuring. So those are those commands. All right, configure as a DHCP client, we just saw DHCP instead of auto config. Verification commands, use them. Show IPv6 DHCP. Use them when you do the lab. All right, relay agent. So same thing, here's your context. Paul. Here's your context. So yes, you do have to go into the interface and IPv4 or v6 doesn't matter. You have to specify an IP address. I wonder if that is required. The outgoing interface, it should be able to figure out what interface it's on based on its IP address. So let's IPv6 DHCP. Why not? Excuse me? Why don't I see that option? Because I'm not doing it right? Nope. Huh. Oh, I wonder If I need to do IPv6. Unicast routing. Oh. Well. I think goes planned. Anyways, just one simple command for relaying agents, or to set the relay. Remember, that's the IP address of the server that you were trying to get it to look at. And then look at that summary on your own time, will ya? It's all the same stuff. A good portion of that chapter should be, at least with the global unique and things like that, that should be review. All right, let me stop this recording.